All right. Last year we failed to do that, and I think this talk is the one that wasn't recorded. And it was like, okay, I'd love to refer to that, but here it is. So yeah, for come on. For those of you who don't know me, I'm Addison Phillips. I am the chair of the Unicode Message Format Working Group. I am also the chair of the W3C Internationalization Working Group. And I am retired from internationalization, and I live in Dillon Beach, which is a couple hours north of here. I am a lifetime Unicode member, and I encourage all of you who are not members of Unicode individually to do that. It's a worthwhile thing. I'm here today to talk about message format. The Message Format Working Group is a working group of the CLDR-TC within Unicode. Our charter is to create a new message formatting standard. We work in GitHub. This is our repo. You can file issues and comments here. You can contribute. You can join our working group and contribute to it. But you'll have to hurry because we're almost done. So what are we going to talk about? I'm going to talk first about why you might want to have a message formatter. Why is message formatting interesting when we have all of these lovely things in like ICU and we have all this CLDR data, and you as internationalization professionals could use that to create your own libraries and formats and things like that. So why do we need that a message format? Then why do we need a new message format, since there already are some in the world? What is message format 2? And then most importantly, what you're all waiting for, when can I have it? And I have an answer to that now. So let's start with why you want a message formatter. And we'll start with the first program almost anyone ever wrote as a software developer. It probably looks something like this. Programming languages differ. I'm going to use Java today as my source of abuse, but the first program you ever wrote has an internationalization bug in it. It has a hard-coded string. And so what we typically teach people to do is you take your strings and you externalize them, you put them into a resource bundle, and you use this thing called a locale. Here we're going to use ESMX, Spanish for Mexico, as an example, to look up the correct resource file and then produce the localized message. So we've solved the IETW bug that you learned as on your first day of programming class as a newbie, right? So what happens to how did that Spanish string get in there? Well, software developers write the business logic, the code, and they write the resource file, the source resource file that contains the string, like hello world. And then there's these other people who are localizers, and the localizers translate the resource files, and those are then added to the application to make it localized into another language. It's important to note there's a separation of concerns here, and there's an importance to that separation. Software developers have a cycle time that is shorter. It's all inside their building or inside their computer, and they can be sitting there coding and testing and checking their code in. They have to check their code in before the translators can start to work on translating the strings. The strings have to exist first. And those people are distributed around the planet. It takes time for them to do their job, to check their work, and so on before. So the cycle times are very, very different. And one presupposes the other. In addition, once an application is built, it's sometimes possible to have translators come on and add a language or a locale to the product without involving any developers. And of course, bear in mind that there are generally a lot more people on the localization side than there are on the software development side. There's one software developer makes the source string, lots of people making different languages on the localization side. So there's more audience for the things that are going on with strings who have to deal with what's going on with those strings on the localization side than just what the software developer needs to deal with. So the second program you ever wrote probably had something like this, hello username, and picking on Java again, it might have, this is the worst internationalization ever, right? It's got hard-coded strings. It's hello plus username plus exclamation point to make that string. And yeah, that's great. But you can go and make a whole bunch of different messages. The red things that you see on the screen here are things that are being inserted at runtime when you're assembling these strings. So let's pick on that one I was just showing. You win percent of your matches. If you mentally match up you win with the front part of these Turkish, Japanese, and Malayalam translations, you're in for a surprise because those words in these languages happen to mean of your matches. So the word reordering won't work if what you have are two discrete strings and the translator sees you win and translates that. They're not going to translate you win as of your matches. You will also be tempted to do things like you win something percent of some other things, and you'll make 14 different right side strings. Well, that's not going to work in all of these different languages. So you need some way to have complete thoughts in your resources so the translators can move the words around so that that's not a problem. They also might need to change the order of the replacement variables because of the needs of different languages. So here are, again, a couple examples where the translations have a different order grammatically than the source material does. But I think the reason that it's interesting to those of us in the internationalization community goes a little bit deeper. So a long time ago, user interfaces tended to look like this, dialog boxy things, label colon something, and developers would then take this, the UX design and go, okay, I can write the code for this. I'm going to get these options and pass it to until date time format, and I'm going to return the string that I'm going to put into the display. So a developer has to understand this internationalization API and its ramifications and how to use it. And I have to go as an internationalization guy and make sure that they understand where the internationalization APIs are and how to use them correctly. And they write this spaghetti into their code to format the date. And then they go to the next line and format a number, and so on and so forth. And I need to chase, you know, when I worked at Amazon, I was chasing 30,000 developers. So it's a bad ratio, you know, 30,000 to 1. And then you get user interface like this, right? So nobody writes dialog boxes relative to this kind of message anymore, right? You last played her on Wednesday, June 14th. You played 10 matches and won 4 of them, right? So you can write this as a wall of spaghetti, each of the little pieces individually programmed using different APIs for dates and numbers and people and so on and so forth, and then write a plural formatter into your code to select which pattern string to get from the resource bundle that you're going to insert all of this stuff into. And notice that there is a tight binding between the code you've just written and how it appears on the display, and you have to teach all the developers to use it correctly all the time. And if you want to change anything about it, they have to go to the code and open the code and change the code. When you change the code, you have to check it in and do code reviews and testing and re-release the application. Why am I going on about this? Well, suppose you had a message formatter, and suppose the message formatter encapsulated all the rules for how to format like numbers and dates and how to do plurals and such. You could have something like message format 1. And so you can have a complete thought sentence. You can have all the instructions in there. And the code looks like the bottom, right? Get the string from somewhere, probably the resource bundle, create a message formatter, package up the arguments you want to insert into it, and format the string. If I want to change the format of something, I go to the resource and change the resource. I don't have to change the code. Now, ICU message format includes additional things beyond just the original stuff that we put in message format 1 that was in Java. So it has plural matching, so we can do the classic thing instead of, if I had $1 for every time somebody wrote if num something equal 1, get this string, else get the plural string, I could retire. Oh, wait, I am retired. Huh. So that was cool, but one of the challenges is that when you have plurals in message format 1, if you have 2 plurals in a string, you need to nest the plurals. And so it kind of starts to look like this, which is lots of curly brackets. And if you understand something about different languages, you'll realize that the English case equals 0, 1, other is one of the simpler ones. Maybe Japanese is a little simpler. But other languages have different grammatical needs, and so they need even more curly brackety stuff to make plurals work. So what's wrong with message format 1? Why are we building a message format 2? Well, message format 1 brings with it a number of challenges. For one thing, there's an old version in the JDK. You can get one in ICU for J. There's a version in ICU for C. It's the end, right? And then people have taken this format and ported it as separate library implementations to various places. It's not built in to the framework or programming language that you are using. It's not built into the resource language that you are using, generally speaking. You have to make a conscious choice to go get message format 1. It would be better if it were built in. Therefore, developers need to learn this thing separately, and they need to relearn it for each platform that they're working on, because it's always a little bit different. Translators do not understand the syntax. We've had this syntax for a long time, but they're not used to seeing it that often. The tooling to support this is not particularly good. Machine translation grokketh it not, and would generally produce garbage out of it. And it doesn't do everything. Message format 1 is still kind of stuck about 10 or 15 years ago in terms of the features that it provides. If we look at ICU's formatters, just at the ones in ICU, string number, date and time, those are we're in message format from back near the beginning of time to that as select and plural, and some support for ordinal numbers, although it's incomplete. And all the other formatters, no, they're not available. You're back to writing that spaghetti code and then spoon feeding it into your message format 1 message. Mission not accomplished. What's more, this select format thing was the only game in town for selecting variations of strings that aren't plurals. So it's the only inflection mechanism people have. So people did all sorts of abusive things in a non-standardized way. And so translators don't know if this select thing is really doing the job for their language or how to deal with it and so on. We call this the bone dragon problem. That's why I have a little picture of a bony dragon thing. And we'll talk a little bit more about that. It's also not customizable. If you write a function, you can't plug it into message format, which is a tragedy because you might need to do something quite specific. We had a presentation yesterday from Netflix about date and time formatting. They have their own date and time formatter wrapper to do Netflix specific things, but they can't plug it in. When I was at Amazon, we did the same thing for currency values. You go to the code and you hack message format and then tell people to use that. That's an approach, but it's not portable, right? Finally, the message format syntax is powerful, but troublesome. So I've highlighted num matches number integer replacement placeholder in this message. That placeholder is 5 curly bracket levels nesting deep in this message. And this formatting is not how you see this message ever. You see it like this. And so if you are a translator, heck, if you're a developer, you are not having a good day when you're writing this message, right? So the temptation is to, well, I'll simplify. We're back to the string concatenation problem, right? You can write this in English, and then the Turkish happens, and you find out that you have played now needs to be in the middle of the sentence, and then you do the =0 case. No automatic inflector thing is going to make that bottom Turkish sentence out of the top Turkish sentence, because it's different, right? The grammatical needs are too vast a change to just feed something in and do an automatic transformation to make it agreeable. And of course, don't forget the plural requirements of other languages are different. The selection requirements, the grammatical requirements are different. And so someone has to take, or some machine has to take the source message and explode it to meet the needs of the target locale. I mentioned the bone dragon problem. In the course of developing MessageFormat 2, there were some strings that were brought up, some cases brought up, and the famous one is you were attacked by a bone dragon. It killed 2 orcs and injured 9 spear carriers. Okay, it's a game message, right? But bone dragon could be replaced with an elf lord or trolls or various different strings, and it's really tempting in English to be able to just do that string concatenation monster thing. And you know, you were verbed by monster and monster pronoun decimation list, right? And you can think about things, large language model, predictive kinds of things, where you can generate this kind of rich sentence in a specific language, and you could use a large language model translation, machine translation combination maybe to generate a bunch of these kinds of messages. And so large language models for the win, right? Lest you think that this never happens in like real software as opposed to game software, you know, you have 2 requests pending, including 1 expense report. Oh, expense report, is that the only kind of thing that can appear in the tail end of this string? Are requests the only kind of thing that, right? This kind of pattern is common in UX design. It's just more interesting to say that this is the bone dragon problem than the expense report problem. So yeah, maybe in the long term, large language model kind of things work, but you're not going to be running a large language model in a limited capacity device like your refrigerator. These things have messages in them now, or I don't care what your limited capacity thing, you won't have a connection to the internet all the time. You don't want to tote around all of this for every language on earth. And inflection will help us eventually, if you saw Marcus and George's presentation yesterday, can help us do some of these things, but that's still coming. It's not arrived yet. So a little bit more about the challenge, and we'll finally talk about MessageFormat 2. So a challenge that we have today is that there are many, many ways to try to solve these problems. And I call that the food supply, which is developers tasked with finding a way to solve all these. And they go to the banquet of open source and proprietary libraries, and they choose a solution that attracts them from the many, many, many ones out there, import that into their product, learn to use it, teach all their translators, and so on. Everybody makes a different choice. Therefore, as an industry, there's no tooling, there's no shared capacity, the machine translation doesn't get any better, and so on. We're not improving overall. So the solution, famous XKCD thing, there were 14 competing standards. Therefore, we volunteered to create a 15th to compete with it. But where I really want to go is into the water supply, right? We want MessageFormat 2's syntax to become built into frameworks and programming environments so that it becomes an assumption that people can build on, you know, so that developers only have to learn this once, and that knowledge is then transportable. I learned to do it in Java, but now I'm going to write some JavaScript, and it works the same way. I'm going to write some code over here in Rust, and that works the same way, and so forth. And ultimately, where I want to go is the air supply. The air supply is developers sit down in front of new environment X and they ask where to put their message format pattern. Right? They assume that it will be there, that this thing will work the way that they expect. When they need a new function, they can plug it in. They know how to plug it in. They know how it's going to work. So message format 2. This is our attempt to solve at least the first core foundational part of this. What is it? For starters, it's a syntax. We have an ABNF syntax, a grammar for messages. We have a specification that says how to interpret all of this, and I couldn't put it all on the screen and have it be any more than some hazy pixels. So you're welcome to go and look at it directly in our repo. What does that syntax look like? Well, this is a message. This is also a message. We call this message a pattern because it has a placeholder in it, although messages without placeholders are also patterns. All string messages are patterns, are valid messages, even strings that don't have anything to format into them. That's kind of important, actually, because it allows us to do things such as attach language or direction metadata to these things so you can format to parts and get that information back. It also means that the translator can go, hey, hello world needs to be inflected in my language, and so I need to insert stuff on this string that doesn't require any decoration in English. If it wasn't going through the message formatting API, that would be garbage on the screen, must change code now, right? So all strings are valid messages. Some have what we call placeholders in them that get replaced at runtime. A placeholder can have what we call an annotation. The annotations consist of a function with a colon in front of it and additional options that allow you to control whatever that function is. Some functions have options, others don't. The options are unique to the specific function in question. The function operates on what we call the operand. In this case, $user is a variable operand. And the functions come from what we call a function set. There's a standard function set that we require every message format 2 implementation to provide. There are optional functions that you are encouraged to provide, but which are not required of you because different platforms may not be able to do specific things. So for example, inserting a string into a message, that's standard. Everybody has to be able to do that. Formatting person names may be something that a specific platform is not ready to do. That would be an optional function, not currently defined in message format 2, but will very likely come very soon. In addition, the implementer can add local functions that are specific to their programming environment or programming language. And ultimately, we want people to be able to plug in their own functions into message format 2 so they can use them without abandoning the syntax and without hacking message format itself. Operands take several different forms. The most common is a variable. So $user, I show $user in Chinese here to show you that you can use different names. The names are not restricted by message format's syntax. You can have literals, those are strings. I quoted Emily's name as a string, and you can have some literals that are unquoted, that don't have any markers around them, including most number representations can be unquoted literals. And then some functions don't require an operand, and you might have just a function. Literals in message format 2 are quoted with pipe symbols on either side. Or if they don't have any spaces and they are conformed to a very much more restricted set of characters, they can be unquoted for convenience. We'll talk, and quoted or uncoded make no difference to message format. They both behave the same. I'll skip over that. So far we've looked at simple messages. Hello world, hello bracket, $user bracket. Those are the simple messages. There's also a complex message syntax. The complex message can start with optional white space that doesn't mean anything, have a series of what we call declarations, and then have a body. So let's talk about those in turn. So let's start with declarations. What's a declaration? Well, you last played on date, but you might want to control all of the finicky little aspects of how that date is formatted. And so therefore you put all these options on there. This is super inconvenient to type. So what you might want to do is say .input $date. I'm going to use the date time function, and here's a bag of options. And then in my pattern, I can just say you last played on date. I don't have to repeat all of the options and whatnot when I do that. That's a .input allows you to annotate a variable that was passed in. You can also write a .local, which is a locally defined variable name, where you can annotate a variable or a literal with a function and additional options. So if you have $date and you've defined it to be a date, I can then do .local time and use the same date value to format that as a time. And then I can insert you last played on date at time into my pattern and have the same variable annotated twice, the same input annotated as two variables. Message format 2 is invariant, so this is not a legal thing where you annotate time twice. This is an error. So those are declarations, inputs and locals. Then you have the body. The body can consist, as you saw on the previous slide, of a quoted pattern. The pattern quotes in message format 2 are doubled curly brackets because we love curly brackets, don't we? We have quotes around the patterns because this allows you to have significant white space inside the pattern. The white space inside a pattern is significant. Therefore, you need something around the outside to tell you where that white space is. Otherwise, they'd all be trimmed. So on the top is our old message format 1 simple plural format. On the bottom is message format 2's equivalent syntax to that. Something to notice here is that we have a selector, which is .match, and it operates on $num matches. Then there's a list of what we call variants. The variants consist of a key and a quoted pattern that's associated with that key. You can have multiple selectors, and unlike message format 1, where we had that sort of nesting syntax that you recall, you just have a list of selectors, and then there's columns of keys that match up to the selectors. So, can I get on that screen? No. So 0 star goes num played num1. 1 goes, the first one goes with num played, and the second one goes with num1, and so forth. If we look at the collapsed syntax without all the pretty white space, message format 1 is a little more verbose than message format 2, almost twice as message format 1's a little bit more efficient. But it's also set up so that you can use white space in your message to make it pretty, and we have sort of a canonical pretty format for message format 2 messages. You can't always use that in your resource file, but you can prettify it for the purposes of editing, which makes it much more approachable. And there's none of this counting how many curly brackets deep you got. You can have an arbitrary number of selectors. Now, I mentioned before that you have to declare the variable with .input or .local, and then you can use it in the selector statement. Why do you have to do that? Well, one of the things that this helps guarantee is that if you declare the variable and then use it in the selector and then use it in a placeholder, the selector and the placeholder are both using the same annotation. So they'll do the same thing. So it's hard to goof it up so that you select the plural format and then add on the decimal part in the formatting, and therefore the selector is doing the wrong thing. They get out of sync with each other because they're both declared earlier. We still have the explosion problem, but it's more amenable to solution. Here's Polish for that, all the permutations that you would need to do Polish for that same message. And I left out the translations because I wanted to put the pretty graphic on here, but you can go and fill in all of those different things. Now, someday we may be able to use inflection to do a bunch of these things because all of the pattern strings that I emitted are just kind of minimally different from one another. And some poor human, well, some machine goes and generates all those, and then some poor human has to post edit all of them. It's a really tedious job, right? A little bit more about the syntax. It's designed to be embeddable. Therefore, there are no Unicode escapes built into it because your programming environment or resource language or whatever probably already has escapes, and we don't want to get into a double escaping nightmare where you escape it in message format 1, and then there's an additional layer of escaping applied on it, and somebody has to figure out when to put it on and off. There are no character escapes like /R or N or T or anything like that. That again belongs to your programming environment and not to message format 2. There are no ASCII quote marks used in the syntax. This is by design to avoid problems with double escaping kinds of things. We're type ignorant. Message format 2 does grokketh not types. It doesn't have types. It doesn't know about types. However, implementations do know about types. And so an implementation can, if you look at like :date_time as a function, it accepts implementation defined date types. What is an implementation defined date type? Well, in Java, that might be any of the java.time types or Java util date, or you know, the vast list of things that are dates. And then you go to JavaScript, and obviously they can't use Java types. They use their own local types, and C would use its own types, and so on. Whatever your implementation needs to do, it can connect to that function and then do the right things under the hood. We have a namespacing scheme for functions. The standard built-in ones that we define have no namespace on them, but for example, ICU could define date interval as a function, and they would prefix it with a namespace like :ICU. You can also have implementation defined options that are added to a function, including a standard function. So here we see :datetime, and maybe Mihai decides I'm going to go ICU skeleton is a feature that I'm going to provide as an option in my implementation. Unicode, that's us, defines 3 options that you ought to implement, but are not required to implement in the :u namespace. Those 3 are :locale, u::locale, u::dir, and u::id. U::locale is for the case where you have a placeholder and you wish to set a different locale for that placeholder than for the string as a whole. So this date looks like this in French. U::locale FR. Right? U::dir allows you to override the base direction of a specific placeholder. This is important when formatting BiDi out. You might need to set this to get the correct markup. And then u::id is mostly for use with things like markup, for being able to associate a value with some external thing. Emily's got a couple of good examples. Maybe we'll do that if we have time. We have an expression annotation mechanism. This is a mechanism for smuggling information to translation systems. These are just ignored by the message formatters. I'm showing an example, but we currently don't have any defined. There's built-in support for markup syntax. This also doesn't do anything in message format 1, but higher level protocols can use this to pass markup information through message format 2 to, for example, generate HTML. I talked about the function sets. Currently, these are the built-in ones: colon, string, number, integer, date, time, date, and time. These are the minimal set. There's an ongoing debate. I think it's pretty likely that we will define currency, unit, and percent as separate functions. Because using number to do that is because 25 years ago, that was how everybody did numbers, right? It's not how we do currencies and units, really, and the options need to be different. So those will probably be split off from number and integer. Little note about white space and BiDi. There's two parts. In the messages, we have a fairly permissive amount of white space so that you can make pretty messages. We also permit BiDi controls of various kinds so that the messages can be read by human beings and deciphered, including when they can contain bidirectional characters. And then on the output side, we encourage BiDi isolating placeholders using the direction of the thing that's being inserted so that you can get good non-spillovery output in straight strings or in format to parts. So we are 4 weeks. We are 4 weeks from shipping this. We didn't quite pull it into CLDR 46. So 46.1 is my release vehicle for the completed, validated thing. So about Thanksgiving time here in the US, we will be done with this work. That will have a bake period, a technical preview period, and in LDML 47, the next CLDR release, I expect us to go to what we call draft, which is truly done. So that's what's there. In that time period, we'll be walking around asking people to pick this thing up and use it in anger. We'll be talking to TG5 and W3C tag, ECMA 402. We'll be bulking up the optional functions from ICU to add to the ones that we require. And we may do some of the additional work that we've left along that we don't actually need to ship this out. And then we'll hopefully have adoption celebrations around the globe by everyone involved. Who has questions?
Thank you. We have time for maybe one or maybe two questions if they're quick. Naboisha.
Just a quick syntax question. So it's going to be quick. So MF1 was nicely encapsulated. So if you say that your plural, it was one message, but you're done, right? When you do dot input or dot type, I think, and then the message, how are those represented in, say, code or resources? So when you have dot input to define,
that's part of the message. So it's
all together, right?
It's all together part of the message. It's not a separate syntax.
One more question over here.
Right here, Sam.
Oh,
The things like the declarations, dot input. I was wondering, like, how much of all of this goes into the code versus into your resource bundles?
All of it goes in. Everything you're seeing there is the message, and it goes in the resource bundle. And so that's really going to what I was showing you earlier on. None of it goes in your code. Your code looks like just like the message format 1 code example, which is if you want to change the message, and you don't have to monkey around with the code at all. So your code no longer is now divorced from that to a great degree. All it needs to do is package up the things that need to go in. So if you need a new variable passed in, you might modify that, but that's it. None of this leaks in here and has to be adjusted over here.
do you think you can ask your question in 30 seconds?
Probably. So I had a question about the BiDi situation. So we don't really know what direction our placeholders will be in a lot of cases. Is there either a built-in dir equals auto on placeholders, or should we just,
Yes.
can we assign that automatically or
There's
manually?
there's that, and then the other thing is that frequently you can get the direction from the locale that you're using, so the formatter might know. If you format a date as in Arabic locale, then you can set dir equal RTL.
And we also have a built-in bidirectional, an algorithm for how do you deal with content and what are you supposed to output when you're not sure of the directionality, for example, of a placeholder. What are the isolation that you apply then?
That's right.
We could be putting an English name in the middle of an Arabic string, for example, and we wouldn't know that dynamically at runtime.
That's right.
And with the default behavior of message format 2, you should get sensible output from either that or if it's the other way around.
And I think we're out of time now, so why don't we give Addison a round of applause?